Okay, so for some reason my last video only recorded about the first minute and a half, and I didn't realize that until I got completely finished with it and uploaded it into Moodle, and one of the students emailed me. So I already have it all written out from the first time I recorded it, so I'm just going to kind of talk you through it rather than writing it all again. But the problem that we were doing was the cosine of 75 degrees, and we talked about how 30 and 45 are both in the unit circle, and I can add those and get 75. So that's what I want to use for my U and V. So what you're going to do now is, since this is a cosine problem and it's addition, you're going to come over here to your cosine addition formula, and that's the one you're going to use. So I have got that formula written down with the U and the V in the correct spot. So everywhere I see a U, I'm putting 30 degrees, and everywhere I see a V, I'm putting 45 degrees. And from here, you're going to use your memorized unit circle values. We know what the cosine of 30 is. We know what the cosine of 45 is from the unit circle. So I'm going to bring this down one step further. So now I've gone in and plugged those in. The cosine of 30 is square root 3 over 2. Cosine of 45 is square root 2 over 2. Minus the sine of 30 is 1/2, and the sine of 45 is square root 2 over 2. Remember, in the unit circle, that sine is always coming from your y values and cosine is coming from your x values. From here, I simplified the fractions. When you multiply two fractions, you always multiply top times top and bottom times bottom. So square root 3 times square root 2 becomes square root 6 over 4, minus 1 times square root 2 is square root 2, and 2 times 2 is 4. And then since these both have the same denominator, I can put those together into one large fraction if you want to, but you don't have to. So square root 6 minus square root 2 over 4 is my answer. I've seen students in the past try to combine these two and say that the square root of 6 minus the square root of 2 is the square root of 4, but mathematically that's not correct. You cannot subtract radicals unless they have the same number inside. So this is how you'll leave your answer. Okay, and we'll talk about this over here in just a second. So the next one that we want to do is the sine of pi twelfths. And what I had done is converted the pi twelfths to degrees, because typically, I think for most people, we're used to degrees a little bit more than radians. And so when you're given an angle in radians, you can always convert it to degrees so that it's a number that you're more comfortable working with. So remember, to do that, I need to multiply by 180 over pi. So my pi's cancel. And so basically in the calculator, you're typing 180 over 12, which is 15 degrees. So I need to come up with two angles in the unit circle that I can add or subtract to get 15. Obviously, because 15 is such a small number, there's not two unit circle angles that I can add to get 15, but I can subtract. And there's a lot of different options here. To get 15, I could do 45 minus 30. I could do 60 minus 45. I could do 135 minus 120. All kinds of options in the unit circle. So just choose what you feel comfortable with, and I think most people are more comfortable with quadrant 1. So I used 60 and 45. All right, and so that makes 60 my U and 45 my V. And this is a subtraction problem, so I'm going to come over here to my sign subtraction rule, and that's what I'm going to use. So then I've got it all written out with my U and V plugged in the appropriate spot. So it's sine 60 cosine 45 minus cosine 60 sine 45. And then I replaced it with its unit circle values. The sine of 60 is square root 3 over 2. Cosine of 45 is square root 2 over 2. Cosine of 60 is 1/2, and sine of 45 is square root 2 over 2. And then we simplify just like last problem. Square root 3 times square root 2 becomes square root 6. 2 times 2 is 4. Same thing here. 1 times square root 2 is square root 2. 2 times 2 is 4. So we get the same answer that we got in the last problem. And so in the last video that got cut short, I was just trying to describe why that happened. If you remember your cofunction identities, and I can just flip over to those really quick. Your cofunction identities say that with sine and cosine, since they are cofunctions of each other, that the sine of one angle is the same as the cosine of its complementary angle, and vice versa. The cosine of an angle is the same as the sine of its complementary angle. Well, 75 and 15 are complements because they add to give you 90, which means that the sine of one and the cosine of the other are going to be the same thing. So this is a perfect example of how those cofunction identities actually work in a real problem. Okay, and then we want to try a tangent example. So tangent of pi twelfths was the one I had on here, and pi twelfths, again, we just found in the previous problem, is really 15 degrees. So what you're really trying to find is the tangent of 15 degrees. Okay, like I said up here, there's several different ways to get 15 degrees. We chose 60 minus 45. Well, with tangent, think about the formula for tangent. This is going to be a subtraction formula. Look at your tangent subtraction formula. You know you're going to have to be finding the tangent of each one of these things individually. So I would choose the combination of numbers that are easy to work with. I know that the tangent, if you have your unit circle memorized, I know that the tangent of 30 is square root 3 over 3. Because tangent, remember, is sine over cosine. And at 30 degrees, the sine is 1/2. The cosine is square root 3 over 2. So when I divide that out, I end up having to rationalize, and I end up with this fraction. But the tangent of 60 is just square root 3, because this fraction's flipped. The sine is square root 3 over 2, and the cosine's 1/2. So this one works out to be a much nicer number. So I chose 60 and 45 rather than 45 and 30 so that I can avoid using that fraction, because you're going to have a fraction anyway, just because the formula itself is a fraction. But putting a smaller fraction into a larger fraction complicates it even more. So when you can avoid multiple fractions, try to do that. So that's why I chose 60 and 45 rather than 45 and 30. If you didn't notice that and you chose 45 and 30, you would still get the same answer. It's just going to take a little bit more work, a little bit more simplifying. Okay, so my U and V, 60 and 45. I'm just going to go ahead and move this and we'll just talk through it. So I've got my formula plugged in, tangent 60 minus tangent 45 over 1 plus tangent 60, tangent 45. So my U's and V's are in the right spot. Then I go to the unit circle. Every time I have a tan 60, I'm putting square root 3. Every time I have a tan 45, I'm putting a 1. Okay, so when I simplify that, the numerator just stays square root 3 minus 1 on top. The denominator, remember that multiplication comes before addition, so I multiply these, which is square root 3, and then I have a plus 1, so I have 1 plus square root 3 in the denominator. All right, this step right here is technically my answer, but in math, we can't leave an answer with a radical in the denominator. That kind of breaks the rules of math. So what we're going to do to fix that is multiply by the conjugate of the denominator. That means you're going to take that middle sign that I had circled here, and you're going to change it, and that makes it the conjugate. So the conjugate of 1 plus square root 3 is 1 minus square root 3. If I multiply the numerator and the denominator by that, I haven't changed the problem any, because something divided by itself is just 1. So this whole thing that I'm multiplying out here is just a 1. So I'm not changing the problem, I'm just changing how I write the problem. All right, so I'm going to FOIL the numerators. First times first is square root 3. Outer times outer is negative 3. Inner times inner is negative 1. And then last times last is square root 3. And then in the denominator, when you multiply a conjugate times a conjugate, what happens is when you FOIL those, the outer and the inner automatically cancel each other out with conjugates. As you can see, the outer here would be negative square root 3. The inner would be positive square root 3, and they cancel each other out. So all I really have to do with conjugates is just first times first, which is 1, and last times last, which is negative 3. All right, and then to simplify a little bit, in the numerator, I can put my integers together. The negative 3 and the negative 1 becomes negative 4. square root 3 and square root 3 becomes 2 square root 3. And then 1 minus 3 becomes negative 2 on the bottom. From here, I think what I did next was I got this negative out of the denominator of my fraction. So to do that, you just change the signs on everything in the numerator, and that gets rid of your negative. So this became a positive 4 and a negative 2, and now that's a positive 2 on the bottom. And then from there, when your three coefficients right here are all divisible by something, you want to go ahead and divide by that to reduce it. So these are all divisible by 2. So that becomes a 2. This 2 becomes a 1, an understood 1. And the 2 on the bottom I don't need anymore since it becomes a 1 as well. So my answer to that problem is 2 minus the square root of 3. Now I want to show you next how you can check these answers. Keep in mind, I said I don't want decimal answers for this, so you don't want to use the calculator to get your answer, but you can use it to check. For example, cosine of 75. Since that's a degree, I can make sure that I'm in degree mode, and I can type in cosine 75, and I get 0.258819, and so on. It keeps going. If I type in this answer, I should get that same decimal if I've done it correctly. Now be careful when you type in fractions like this. You may need to add an extra set of parentheses in the numerator to keep it separated. So I've got square root 6 minus square root 2, close that parenthesis, and then divide by 4, and notice I get the exact same decimal. Okay, so that'll always happen if you've done it correctly. It works with radians as well. Let's go down here and check the tangent one. Tangent of pi twelfths, if I wanted to go to radian mode, I could type in tangent pi twelfths, which gives me 0.2679. Then I can come down here and type in 2 minus square root 3, and I should get 0.2679. So you are free to check your answers. I just don't want decimal answers on a test or a quiz or anything like that. We always want exact answers.